Right, good day and welcome. In this lesson, we're looking at riders, Theorem 1. When we say riders, it simply means we're giving you Euclidean geometry, but now instead of giving you angles and length in centimeters and degrees, we use variables as unknowns, and we used to have to use the variables x and y, z, etc. to solve problems. So in the diagram below, this is from June 2017, grade 11, paper 2. Diagram below, O is the center of the circle, BC equal y and PO equal x. They want us to determine PT in terms of KT, so they want PT in terms of KT. At the same time, we have to prove KC squared there equal 2xy plus 2y squared. Let's solve the problem. Determine PT in terms of KT. We assume you remember Theorem 1, right? If I draw a line from a center and it meets a chord at 90 degrees, it cut that chord into two equal halves according to Theorem 1. So there I can simply say PT equal to half the length of KT, line from center, perpendicular to chord. So you see the line from the center is perpendicular to that chord. Right, so that one's done. Look at the second problem. Right, prove that KC squared equal 2xy plus 2y squared. So first, I'm going to join O to K. I'm going to draw OK. And from here, I'm going to work out the length of KP. That way I have two knowns for there so that I can find KC. Right, so I assume you know from C to O, that's a radius. So my radius length is x plus y. If I draw from O to the radius circumference there at K, that is also x plus y. So in triangle COP, KOP, I can say KP squared equal to the longer side, x plus y squared minus x squared. Right? X times x squared. For the middle term, x times y times 2 gives me 2xy. Y times y gives me y squared minus x squared. X squared minus x squared cancels, so I'm left with 2xy plus y squared. So now Kp there is 2xy plus y squared. So if I say in triangle KCP, remember there's automatically 90. If this is 90 angles in a straight line, that's 90, that angle 90, in that order. So now I can say KC squared, which is opposite of 90 degrees, my hypotenuse or longer side, equal Kp squared plus Cp squared. So Kp 2xy plus y squared, Cp squared, y squared, right? Y squared plus y squared then gives me 2y squared. So there I've proven that Kc squared equal 2xy plus 2y squared. Let's look at the second example. So if we look at November 2018, paper 2, grade 11. Yeah, I'm just doing riders on Theorem 1. We will still do riders where we have to prove cyclic quad, that line is parallel, that is a tangent, etc. Right, so in the diagram, O is the center of the circle. Chord AC is perpendicular, so there my perpendicular 90 degrees to radius OD. OB, from O to B is 2x units. From A to C equal 8x units. Show that the length of PD, the small piece here, equal 2x times square root 5 minus 1 unit. Right, so let's look at this. Alright, so they said OB equal 2x. AC is 8x, but the line from center is perpendicular to the chord AC. Therefore divides that 8x into two equal sides, so AB equal BC, and they both are 4x. The right angle triangle, so from there I have two sides. I can work out the radius, which is opposite the 90 degrees. So OA squared, the longer side, equal 2x squared plus 4x squared. 2 times 2 would give me 4. X times x squared. 4 times 4 is 16, x times x squared. 4x squared plus 16x squared would give me 20x squared. To get OA, I have to find the square root of OA squared, so therefore square root 20x squared. If If I press square root 20 in a calculator, I would get 2 square root 5. But that's because the perfect square in 20 is 4. 4 times 5. X squared, square root 4 gives me 2. Square root of x squared, x. And square root 5 simply stays behind because it's a prime number. So therefore, my whole radius now from O to D equal 2x square root 5. So if I want PD, it would be 2x square root 5 minus the 2x. Take out the common factor 2x. I'm left with square root 5 minus 1. So there I solved for PD. So hope you follow, hope you enjoy the lesson. Wish you nothing but the best. I'll do all the different various riders and so on. Do as many as possible before June exam comes up. Promise takes quite some time to draw all these drawings. But continue practicing, continue becoming the best version of yourself. Bye.